right, so chapter 11, like we said, starts to get into, eventually we'll get into areas of all different kinds of polygons, but we start with, in section 1, circumference and arc length. So we're still in circles. Circumference, which is something that you've heard for a lot of years, hopefully, is the distance around the circle. It's like the perimeter of a circle. And there are two formulas you can use because they're interchangeable. One is circumference equals pi times diameter. Or because the radius would be 2 times the radius is the diameter, you can also use 2 pi r. So if you have the diameter, I would do pi d. If I have the radius, I would do 2 pi r. You'll see these questions, 2 different sets of instructions. One is actually 3. Use pi on the calculator, and so you would actually use the pi button on the calculator. The other is use pi is 3.14, so you'll approximate pi to be 3.14. Actually, 4 ways. Sometimes it will say estimate pi to be 22/7, and so you can use that. Lastly, you'll keep in terms of pi, which means you keep pi, like the actual symbol, in your answer. So with a calculator, you could do any of the ones on the left. Without a calculator, you would just keep it in terms of pi. This one would be exact. This is the only one. This is exact. And all of these would be rounded. So if it said keep your answer exact, then you're keeping it in terms of pi. So when we get into examples, we'll talk about the difference. All right, the second formula, well, third, if you count that there are 2 for circumference, is arc length. So arc length is a portion of the circumference of the circle. It is part of the crust of the pie, if you think about it that way. And you can use the measure of the arc in degrees to find its length. So in a circle, the ratio of the length of the given arc to the circumference is equal to the ratio of the measure of the arc to 360. You are going to take the arc measure, so the degrees of the arc, which we've been doing from last chapter, put it over 360, and then multiply it times the circumference. So this is the formula you want to know. Measure of the arc over 360 times 2 pi r, or the measure of the arc over 360 times circumference, if it gave you that, or the measure of the arc over 360 times pi d. All of those are interchangeable. So if they gave you the circumference, you just multiply the 2 together. If they give you the diameter, then I multiply it times pi and multiply it times the measure of the arc over 360. And if I have the radius, which is what normally you're given, I would do the measure of the arc over 360 times 2 pi r.
What is circumference?
The distance all the way around the circle. So like the perimeter of the circle. Because we're talking about length this time, the answer would be, if it gave you a unit, it would be like centimeters or inches or millimeters, something like that, instead of degrees. So the unit of measurement is length. All right, example 1. Find the circumference of a circle with a diameter of 5 inches. Leave your answer in terms of pi, and then use 3.14 for pi. So we're going to do this 2 ways. The circumference, which in this time they give me diameter, so this would be pi times d. Pi is going to get left in there, and then d is the diameter, and literally I just switch the order. So it's 5 pi. So that's what it would be in terms of pi, and it would be inches if it asks for a unit. So that's the first way to do it.
What is in terms of pi mean?
In terms of pi means you keep pi in your answer like we just did, like pi stays there.
And then when it's not in terms of pi, what happens?
The second thing says use 3.14 for pi, so then I would take 5 and I would multiply it times 3.14. So 3.14 times 5. Which is 15.7 inches. So when it says to use 3.14, in place of the pi, we put the 3.14. If you have your calculators, take them out. Okay. If you don't have it, it's okay. Just there's going to be times in which you're going to want to use it. Above, like on the left-hand side, above. All right, so above the little, there's that little caret that looks like an arrow. Like that's where your pi button is. Locate your pi button. If I did 5 times pi and it wanted you to round it to more decimal places, then it would be 15.7079, so on and so forth. Okay, so if you actually had to use the pi button, it would go more decimal places, and it will tell you what to round to. Everybody located pi? Yes? Okay. It's on. All right, B says find the radius of a circle with circumference 17 pi feet. Now I have the circumference, I want the radius, so I can use 2 pi r as my formula. Or I could use pi d and then have to cut it in half. It's the same thing. So if circumference is 17 pi and this equals 2 pi r, how do I isolate r?
So you would like divide 17 by 2.
I can divide 17 by 2. So it's going to cancel. I get pi r equals, this would be 17 over 2 pi, or 8.5 pi. And then what?
Oh, I thought you wanted to isolate r.
I do.
Oh, so divide pi.
Divide by pi. And it cancels from both sides. So r is 8.5 or 17 over 2. Both of those would be exact. You could use either one. And this time it's feet.
Yes, I was like 17 pi divided by 2 pi.
So yeah, I would have divided by both at the same time, which is what you can do. 2 pi r. You can actually divide both sides by 2 pi. So they cancel from here, and r would equal the pi's cancel, 17 over 2, which is 8.5.
Or you could just know that 17 is divided by 2.
Sure, and then you still have to cut it in half, right? You still have to divide by 2. Same thing. Questions? All right. Example 2 says find the diameter of a circle with circumference 16 feet and use the calculator and round to the nearest hundredth. So this time we're looking for diameter, so I'm going to use C equals pi times D. Circumference is just 16, not 16 pi. And then if I wanted to find D, I'm going to divide both sides by pi, and I'm going to use the calculator to take 16 and divide it by pi. And round to the nearest hundredth. How many decimal places is that? Nearest hundredth is 2. Good. So diameter 5.09, and it's in feet. Questions on that one?
So are all these questions the exact same?
No. Look at B. A car tire has a diameter of 28 inches. How many revolutions does the tire make while traveling 500 feet? What's a revolution? One full circle, right? So on a tire, which is obviously circular, one revolution is the same thing as one circumference, right? So I'm going to use the diameter to find the circumference of my wheel. So 28 pi would be the circumference, and that would be one complete revolution would cover that. So if it's saying how many revolutions does it take to go 500 feet, how do I find it? Divide. So I'm going to take the 500, that's the total distance traveled, and divide by how much is traveled in one revolution, which is 28 pi for one revolution. So I get 500 divided by, and I have to group together the 28 pi. So you could do 28 pi first, Or you could do 500 divided by 28 pi.
Do we always round to the 100?
No, just pay attention to what it tells you. This time it says tenth, right?
Oh.
Yeah. So this would be 5.68, which rounds to 5.7. It's a great standardized test question because it takes something that you know, like circumference, and there's some application to it. Questions on that one?
Wait, how did you calculate?
Yeah.
We have to do 500 divided by 28 pi. Did I do that right? 500 divided by 28 pi. Yeah, but you have to group together the 28. Like this has to be multiplied first. If you do 500 divided by 28 pi, your calculator will first divide 500 by 28 and then multiply by pi.
So then how do we do it though?
You put it in parentheses, or you multiply 28 by pi first and then do 500 divided by that answer. So I think it's easiest to use your parentheses. So I would do 500 divided by, open the parentheses, 28 pi on the calculator. Or you do 28 pi, you get an answer from that, which is 87.9645, so on. And you could do 500 divided by ANS, which is going to pull up the last answer. So instead of typing in that whole thing, you can hit the ANS button, which is above the negative button, and it will bring back your last answer. So 5.7 is the number of revolutions it takes. Questions on that one? Okay, now we get into the arc length. So this says find the indicated measure, and A is the length of PQ. Remember, length is not the same as measure. If it asks for the measure of PQ, what would be the answer? Good. It's a central angle given. The arc's the same as the angle. So the formula for this is the measure of the arc, in this case it's PQ, over 360, times, I'm given the diameter. I know it's the diameter because it's in the middle like that. So I would do times pi d. So the measure of PQ is 75 over 360 times 9 times pi. It says keep answers in terms of pi, so we're just going to simplify this as much as we can, but keep it as an improper or proper fraction as long as it's simplified. So both of these would go over 1. All right, 9 goes into 360 40 times, and then 75 and 40 are both divisible by 5. This would be 15, and this would be 8. So in the numerator, what I have left is the 15 and the pi. In the denominator, I have left the 8. And in yards would be the measurement. So if it says keep answers in terms of pi, you're keeping it exact like that. Yep. Or pi d. Those are interchangeable. So this could be either one. If it gave me the radius, I would use 2 pi r. If it gives you the diameter, you can just do pi d. Yeah. All right, B says to find the circumference of the circle. If you're given, this is the actual arc length of L to M. If there was another letter there, it would be named that.
That's 60?
That says 60 pi.
It looks like
It's 60 pi meters, right, for length. So the measure, again, if there was another letter here like M, N, M would be the name of that arc. What would be the measure of that arc? Length. 270 would be the measure of that arc over 360. And then we can either use 2 pi r, or we can use pi d, or we can use circumference there, which is what you're actually looking for. So 270 over 360 times the circumference gives you the arc length, which is 60 pi. I can cross through the zeros here. And then what goes into both 27 and 36? 9. It would be 3/4 times the circumference equals 60 pi. Now what?
Now we divide by 6.
I want to isolate this C, right? By the way, flip it, right? I can multiply by the reciprocal, which is 4/3, or you could have done that in 2 steps. I could have multiplied by 4 and then divided by 3. So it cancels from here. Circumference is the only thing left, which is what we want. And then 3 goes into 60 20 times, and 20 times 4 would be 80 pi. And it's in meters. Questions on that one? If it had said to round it or use 3.14, obviously I'd use the calculator. But because it said keep answers in terms of pi, I keep it exact like that. All right, example 4. Now the instructions say find the indicated measure and use the calculator and round the answer to the nearest tenth. So now we're using the calculator. For A, it's looking for circumference again. And again, it's giving me the length of this arc. So the length of the arc equals the measure of the arc over 360 times, if I wanted diameter, I would do pi d. If I wanted radius, I would do pi r. If it wants circumference like it does, I can actually just multiply it times c. And then fill in the information that you know. So the length is 61.26. What's the measure of the arc? 270. And I'm looking for the circumference. So I can use my calculator already if I wanted to. I could literally multiply this by 360 over 270, and I could do the same thing over here. 360 over 270. Or I could have simplified and then done it. It doesn't matter because you have the calculator. It doesn't matter what order you do that in. So I would do 61.26 times 360 divided by 270. So in the calculator, I did 61.26 times 360, and then I took that answer and divided it by 270. And circumference is 81.68. This time it's meters. All right, B, you're given the length and the measure again, and this time we're looking for the radius. So I'm going to use that the length equals the measure of the arc over 360 times, if I want radius, I use 2 pi r. The length is what?
10.5.
Good. What's the measure of the arc? 150 over 360 times 2 pi r.
Why aren't you doing C?
Because I want to get to the radius this time. I could do C, but then I'd have to do C equals 2 pi r, so you might as well just do it now. How do I isolate the r?
Multiply everything by 360 over 150.
I could do everything by 360 over 150. So that's gone. And 360 times 10.5 divided by 150 is 25.2. And then how do I isolate the r?
Divide by 2.
And good. So if I do that in one step, I have to group them in the parentheses. 2 pi has to go in parentheses. This is 4.01. If you do it separately, you could do 25 divided 0.2 divided by 2, and then take that answer and divide it by pi. You should eventually get that. It is 4.01 and it says round to nearest tenth. So it's 4.0 feet. Questions on that one? Because this, right, they give the 2 pi, 2 would go into 360, 180 times. So it's the same thing. It says it here, multiply the degree by this. So we just, this just simplifies it. The angle times it. It's just, I use this one instead of the first one. That's all. It's the same thing. It's just written in a different way. So for A, we converted degrees to radians. We took the 15 degrees and multiplied it times pi over 180. And then cross-canceled and ended up with pi over 12 radians. For B, we're going the other directions. We want to go radian to degrees. So 4 pi over 3 gets multiplied times 180 over pi. The pi's cancel because they're diagonal from each other. And then 3 goes into 180 how many times?
60.
60 times. What's left in the numerator is the 4 and the 60. So 240, and there's nothing left in the bottom. And we mark it with the degrees symbol. So you want to make sure you distinguish between the radians and the degrees. Radians, you literally write the word radians, and degrees, you put the degree symbol. Relatively easy stuff, yes? 3 formulas: circumference, arc length, and then, well, 4. Degrees to radians, radians to degrees. The conversion part? Or the whole thing?
The formulas you gave us are different than the formulas.
What do you mean? You need arc length, which is the measure of the arc, over 360, times either pi d, or times 2 pi r, or times c. You can use any of those 3. And then the degrees to radians is the angle times pi over 180. And the radians to degree is the angle times 180 over pi. That's everything you need to know from this section.